Awesome. Thanks, Bill. Well, it's been great to get the chance to meet everyone here today. I'm really excited to talk about storage, and it seems like the level of blockchain understanding is a little bit lower than where I want it to be. So I'm going to start off. I'm going to give you guys a quick high-level overview in terms of what blockchain is and really focus on the key business value, meaning how can we reduce costs and how can we create opportunities for new revenue? Because that's really why we're all here as CIOs, is to kind of create efficiency in the business process. And so with that, I'll give you guys a little bit of background on me. My name's Kevin Leffew. I'm a business development manager at Storj Labs. And so at Storj Labs, we're building kind of the next generation of cloud without hosting any infrastructure. And I'll get into a deeper explanation of storage later. I'm going to start with blockchain. But as a little bit more background, I joined Storj from Microsoft. I was on the Azure Blockchain Workbench team, on the extended engineering team, contributed to some documentation, worked closely with the team on strategy, and used to give a lot of presentations around Workbench. So I know we had a lot of people here interested in Power BI. I have guides on my Medium page about how to take smart contract data in Azure Blockchain Workbench and express it through Power BI, which is a tool that a lot of you guys are already using. So just check out my Medium page for that. I'm really active in the DC hackathon and meetup scene. I'm an active contributor to open source. I was a contributor to Mastering Ethereum, which is an O'Reilly book getting launched this year. That's really a technical deep dive into the inner workings of Ethereum and distributed ledger technology. And with that, and I'm also a Teams expert too. So I know you guys are interested in Teams, so happy to talk about that as well. But we're going to focus on blockchain today. So let's do a quick overview of blockchain first. So what is a blockchain? It's not really the blockchain, well, yet. We don't have an internet of blockchains. Right now, it's a blockchain. And a blockchain is really a globally distributed and shared public ledger of all transactions. So really what that means, we can think of a ledger in accounting, right? This is a really kind of important concept where if we look back at some of the earliest cave drawings in France, we see that there were ledgers, right? So people taking record of ones and zeros, right? So like who has what and why and when. So it's a really important concept, and being able to digitize this concept of a ledger, is really the key innovation behind blockchain. So quick explanation, blockchain is a database that's append only, that's distributed to every single participant, and they're all kind of in sync. They're all gossiping to each other on a peer-to-peer network, where if a transaction gets validated, it gets flooded to every single other network participant globally. And so when you have like hundreds of thousands of nodes, that makes for a really, really, really resilient system from a security standpoint, where to really like erase the blockchain or shut it down, you need to shut down every single node. The whole blockchain could repopulate from one node that has a copy of the blockchain. And given that there are copies of the blockchain in space, underwater, it's a pretty resilient system and tough system to hack, given kind of those security constraints. So data and state are stored in a ledger. We just kind of touched on that. So we could think of an accounting ledger. It's append only, right? So John sends a payment to Dennis of $500. That gets registered and it gets sent to every single active participant. So it's all public. It's permissionless and it gets sent everywhere. But it's not just for money, right? Money is kind of that first use case that Bitcoin tackled, and it's really interesting, and it's a really transformative use case, but it's not the only use case. We can actually create any kind of representable, like unique digital asset where it's provably scarce. And so that could be something like a sword in a video game, right? So tomorrow there's a company called CryptoPets that's launching in DC. You can think of that as Pokemon Go, but the developers can't create any new Pokemon, right? These are CryptoPets. These are things that you own. You can battle them. You can level them up. And they have monetary value. I could buy them from someone else in kind of a peer-to-peer way. And if they die forever. And so I think that's really interesting, and that's another DC startup where they're launching tomorrow. And it also, right, when we kind of move from this ledger to this global computer kind of concept, which is what Ethereum is, it's this blockchain 2.0, where you have a Turing-complete state. You have a virtual machine that's distributed globally. You can start doing these things called smart contracts, which are decentralized applications where there's no single point of failure, and they're distributed globally. We can talk about what the implications of that are in just a second. And so again, right, data is shared in a blockchain network. Instead of having one central IT shop, one central database where all that data is held, everyone shares it. It's spread amongst every single participant. And it's really awesome, right? Because by doing that, you're removing the stronghold, the center like intermediary that just holds data and can charge a fee, right? So, we can think of like things like interchange fees, right, with credit cards, where every time we do a transaction, right, you have to pay a certain amount. And if you look at the mobile payment stack, right, there are these kind of explicit interchange fees, and then there's these implicit fees, these risks of chargeback fees. But there's also hidden implicit fees around data, right? So credit card companies and Apple Pay and all these companies have access to our data. And that's a really important concept to understand with these centralized systems versus these decentralized shared systems. And so these are some core concepts that I'll just really quickly touch on. The whole breadth of blockchain is so deep that I could teach a whole week-long class on it, but I won't do that. So we have decentralized applications, which are applications that are running on Turing-complete blockchains like Ethereum that are distributed globally, that have no central points of failure. We have distributed ledgers, right, which is what we talked about earlier. We have encryption, so we, hopefully as CISOs and CIOs and security experts, we have some understanding of encryption. Blockchain kind of takes this concept of public key cryptography and ties it to identity. And so kind of in a way that's similar to PGP, but it creates a global decentralized registry of public key addresses and address spaces. We can talk about that in a second too, right? But really quickly, the awesome thing is, right, blockchain's pseudonymous, so you could generate a private-public key pair offline and use that to sign cryptographically verified messages, and it never touches the internet, and it all happened offline, and that's what we call a cold storage wallet. But there's really kind of unique digital identity and digital security implications that kind of come out of blockchain. Another key concept is that it's trustless. There's no person you have to rely on for trust, right? So a trusted third party is a security hole. That's a quote by Nick Szabo, who is a security expert and also it led to some of the precursors of Bitcoin. So his trusted third party is not only a security hole, but it's also a monetary hole. Like they're probably taking some kind of a piece of the pie. And so when we're moving to blockchain, we're moving to zero trust systems where we trust that if something happens, if we execute this code, it'll be executed globally, and we don't have to trust anyone to verify it because everyone verifies it. And then we have proof of work. So who here knows what proof of work is? It was originally invented by a guy named Adam Beck to be used as a spam filter for email. Essentially what proof of work is do you guys know what hashing algorithms are? You take any kind of chunk of data and you, as an input, and then as an output, you have just a data of arbitrary length. So say it's 256 bytes, right, would be the output. And so it's deterministic, but it's non-predictive. So you can't predict the output from the input, and it's a one-way function. So you can't go from this output, this kind of unique hash fingerprint. It's also called digital fingerprint, back to the input. So proof of work is used in Bitcoin to create a fair kind of game theoretical incentive mechanism for people to verify the whole blockchain. And you can definitely go deeper into that. And then we have cryptocurrency, which is things like Bitcoin, Litecoin, Ethereum, these blockchain-based tokens that are basically powered by people that are verifying the integrity of the system. And so we can go deeper into that, but I'm going to go a couple slides up here first. So let's go through a quick example, of a blockchain transaction. What happens is someone who's generated a private public key pair signs a message. That message is saying, I'm taking, first of all, you're proving I have 1 Bitcoin and I am moving it to this other address. That gets verified that yes, this person has enough, right? And then basically then gets flooded across the network. So then everyone agrees, there's consensus. It gets mined into the block. That block gets propagated across the whole network. And then we've reached consensus around the state of the network. We get a global state. So this is kind of just an overview. So after a transaction is verified, it gets placed in basically a queue or a mempool is what it's called. Miners grab them up. Basically, they're all kind of competing to solve this proof of work puzzle. If they solve it, they have the right to put some transactions in the next block, and they also get a reward for doing that. And so it creates an incentive. But mining's computationally inefficient, right? It's not really It's not like looking for for patterns or anything. It's completely arbitrary, and we'll get into why that's important later. And so again, kind of one last thing about privacy and security in blockchain, right? It's meant to be an untrusted system, so all nodes are untrusted, and actually the system gains resilience by untrusted nodes all kind of coming together and agreeing. So, I don't have to trust that, I don't have to trust you because, I know that because you're running this protocol layer, you're gonna, have to come to consensus with the network, because if you don't, then you're gonna get cut off, and then you're not part of the network anymore. And so nodes are entrusted, and it's a system that actually it gains from kind of this untrusted node system. So encryption helps remove this trust. All transactions are cryptographically signed using PKI, and they're all stored on this public ledger. And so in blockchain, your encryption keys are really your wallet and also kind of your identity. And that's kind of some of the base primitive of this system and how it works for people who are kind of completely non-exposed to it. So again, if you don't know what public and private keys are, one way to think of it is your public key is kind of like your address, and your private key is your password. And so a private key is a cryptographic secret that you don't want anyone else to know about. And so generally you'd hold it in cold storage. Or you would use a seed to generate a private key, and you'd store that seed on a piece of paper and put it in a bank vault, so you'd always recover it. But your private key is kind of like the core of the identity in the system. And then one of the advantages of that is you have distributed identity. So right now, if you think of Equifax, you think of these companies that have gotten their databases hacked, where they have a big SQL database of usernames and passwords. That's a big security risk. It's a honeypot for hackers, because if you break into that system, then you get all the username and passwords. With this, you have to individually crack each single private key to find access to each private key. So there's no one central honeypot for attack, and that kind of helps disperse some security risks. And so just to kind of recap, these are really the 4 core pillars of blockchain. It's shared, so everyone has a copy of this ledger. It's secure through cryptography techniques. It's distributed, kind of along the same lines of shared, and it's a ledger, so it's append only. You can only add to it. And so how do we apply it? So that's kind of the base overview. I'm sure some of you have heard it before, because blockchain is always in the news now. But so how do we apply it in an enterprise setting where we can reduce costs and create opportunities for new revenue, because that's what we care about. We'll hear a couple of use cases. We'll actually use a lot of use cases. And we're not going to go into all of them. I'm just going to go into a couple of them. I think one interesting one is supply chain, right? So we can think of these smart contracts as being ways to measure, or when we start bringing in things like IoT data, and we start thinking okay, so we're bringing in telemetry data, and we're maybe bringing a milk, kind of across borders and across suppliers that don't trust each other, and they have different ERP systems, and they don't have a shared source of truth. Blockchain can help, enable digital transformations so that they do have a shared source of truth, and we can use smart contracts to say, while it was in this person's possession and it was being monitored by this IT device, it didn't exceed this temperature threshold, and if it did, then they violated these terms. And then there's some kind of if X, then Y type scenario that we can start integrating in. So I think supply chain is interesting. I know some people here are in healthcare, so I'm going to go deep into healthcare. But first, these are just, I'm kind of an active open source participant in the DC area. Some projects that I've worked on are things like proof of file integrity. So taking a file and taking that unique thumbprint, that one-way hash output, storing that on the blockchain allows for a really efficient digital timestamping mechanism. So you have some kind of authoritative proof that this file has not changed since this point in time that's verified globally. You can kind of think about why that might be valuable, right? So not one bit has changed in this file. Blockchain is probably the best timestamping mechanism that we've access to for proving file integrity. For pharmaceutical script verification, I won a hackathon at Georgetown for basically creating a non-fungible token or a smart contract where instead of having a piece of paper where you could have a forged signature using public key cryptography so that you can't forge a signature. It's impossible. And instead of using the e-pharmacy system where a doctor gives a pharmacy directly to the supplier, which can create vendor lock-in, it can create misaligned preferences. This is something that can be peer-to-peer. So a doctor could directly give a digital prescription to someone that's cryptographically verified, provably unique, and then transferred to a pharmacy. You can monetize social media following, so you can create an auction, right? So who gets my next tweet? I'm going to auction off my next tweet, right? That's kind of another interesting use case, and that's called token broadcast. And these are all on my GitHub, so you guys can check all that out if you're interested. And also, right, I don't know if you guys are familiar with like, economics and game theory, but finding a Schelling point, right? So like, how do we get truth outside of the blockchain into a smart contract? That's called the Oracle problem. And it's not related to Oracle, the company. It's related to Oracle in the sense of blockchain, meaning any data that resides outside of the chain. And so we basically worked on a project where we said, okay, if did it rain today, or what's the temperature in Laurel, Maryland right now? We have a competition, and if you're putting in this work, you're putting this computational resource, it creates kind of an economic like bucket you're putting things into, and you're incentivized to then also give an answer. So we're taking the proof of work principle. We're also plugging in an answer, and then we're taking the median value of a set of answers, and then that becomes the truth for the smart contract. So we have like kind of a competition for who submits this value. Then we take the median value, and that becomes the source of truth for the smart contract. And I can get deeper into that, but I don't want to spend too much time on it. All that stuff's on my GitHub and pretty well documented. Whoops. Bloop, bloop. I'm going to skip the supply chain use case, right? We can think about monitoring supply chain. But what I want to talk about is blockchain and healthcare records, because it's really important, right? I think we've all seen in the news companies like, taking people's personal healthcare data and selling it, right? And so, we don't want that, right? We don't want like a future where people don't own their own data, right? This kind of, what really I think the core value proposition of blockchain is that it creates a new standard for digital ownership of our own data. And I think that's really important. And so, we're kind of coming at this crossroads of all this interesting stuff happening in healthcare. We're getting genomic data and ancestry data and epigenetic data and traditional medical records. But like, who owns it? How are they transferred? Right? Do I have the right to my own data, or does the person who took or does Apple have the right to my data because my Apple Watch, gathered this data and then it's stored in some cloud somewhere, right? So it's really important for us to have access to our own data and then be able to selectively give it out for periods of time. And these are all standards that are kind of being built out with blockchain. And so I'm part of something called the Decentralized Identity Foundation, which is like Microsoft, IBM, Blockstack, all these cool companies that are working together to create a foundation for digital identity and ownership where you log in with the blockchain with your own, you're verifying yourself using public key cryptography, and it's not like some cloud provider owns your identity. It's not sign in with X company, it's you own your own identity. You have a series of attestations that say, this is my name, this is my favorite color, whatever. It's stored in an encrypted off-chain database, then it's selectively given out. And that's kind of a new standard of identity. It's a new protocol standard for the internet. It's really interesting. And so what if patients could control their own data? What would that mean? Well, we'd be able to overcome some of these silos, and we have a single source of truth that's attested to by the patients themselves. Well, that would be pretty cool. We can ensure privacy and security through encryption, and have digital storage basically managed by the patient, where they're not at risk of losing their data either, because it's distributed. And we could really achieve better outcomes through transparent and complete and really unalterable or immutable data sets at scale. So there are a lot of really interesting value propositions around healthcare, and there are all kinds of people researching this. But I noticed a lot of people here had kind of backgrounds in healthcare, so that's why I chose this as one specific application before I went into what we're doing at Storj. And so we could think, encryption and erasure encoding basically means that like only you have access to this data, and it's not hackable. It's not. There's not one database, right, where you're trusting someone to hold it, that they could be hacked, and then that's a security hole. That's a third party. Every third party is a security hole, and so we're kind of changing that paradigm, and we are creating a paradigm where it's like less prone to human error, right? Like you're not going to accidentally have like some IT manager get the whole database hacked. Lower cost for transactions, and really a less sticky system. And so we could start doing things too with smart contracts to say who and when and how long people have access to this medical data, right? And that's really important because we don't want everyone to have really deep profiles about us, because then if they do, they can influence us in subtle ways that we don't really understand. We even see that kind of in the advertising industry, right? So it's really important for us to own our own healthcare data and have that encrypted and distributed. And so just kind of to wrap up, the core difference between a decentralized application and a centralized application is with a centralized application, we have one central point of failure where if the center breaks, the whole thing falls apart. Decentralized applications function much more like a mesh, where it doesn't matter. We can start plucking out nodes left and right. and the output in the single source of truth, the shared truth, is going to remain the same. And so there are a lot of values to that. We're creating kind of this mesh network or swarm network that's fundamentally different than like centralized cloud. So right, the kind of key concepts are like, distributed system consensus. How do we all arrive at the same truth and at the same state output? How do we distribute data? How do we make it transparent? How do we have security through math and through encryption and do this in a way that's trustless without third parties? And so that brings me to storage. And so that was the blockchain. Now I'm going to talk about storage, which is an application of the blockchain to really change the way that we see cloud and move from this like centralized, like, I give my data to a data custodian and they host it and I trust them, to a trustless model that's decentralized, but still interoperable with protocols that we know and love, like S3. So let's go ahead and talk about storage. So storage, we're Storj Labs. We're building the storage protocol. We're a platform, so you can build on top of us. And we're a utility token and a suite of applications. We're really focused on creating a new paradigm for cloud storage that's private by design and secure by default. And so we enable applications to store and share data on a distributed, end-to-end, and encrypted cloud storage network that's secure, reliable, and efficient. And I'll get deeper into that in just a second. But kind of the key thing here is like we're not storing data on the blockchain. We're doing a secure, like peer-to-peer encrypted system or node-to-node encrypted system where if I want to store data on this network, what that also means is that we can do things like parallel packet streaming to overcome like latency bottlenecks. So, right, whatever like 10 packets get to me first, that reconstitutes the file and that can overcome like traditional latency bottlenecks. And we can do hyperlocal content delivery eventually, and all that kind of cool stuff. So storage has been in the press a lot recently. We got I don't know if you guys have heard of Docker. It's probably like the standard for containerization. Ben Golub recently joined Storj from Docker. So he's our CEO. I don't know if you guys have seen Silicon Valley, but we've been around since 2014. There was this whole concept with Pied Piper. They're rebuilding a new internet that's like peer-to-peer and distributed. A lot of that was based off of us and what we're doing. And right, we've been featured in like NASDAQ and Wired and TechCrunch and all these cool publications, but we're still really a small team. And I think we're doing something really cool. And that's what we're doing in the news. So let's kind of talk about what we're doing, right? So the cloud storage industry right now is $92 billion. It's huge. So that's the total addressable market. You can imagine like 1% of that is like highly significant. 0.1% of that is highly significant. And there are a lot of issues, right? We see this whole stuff with GDPR, and people are now starting to understand like, I don't want other people to own my data. Your data is you in the digital world. Like you need to own it. If you don't own it, then someone else is like almost like owning you, right? And so there are all these privacy and security issues, and we think that we can help solve them. And so right now, file storage is exposed. It might be unencrypted. It might be ripe for attack. It's an essential database. There's a honeypot. Creates a natural like economic incentive for people to hack it. And instead, we're kind of moving to a privacy by design, client-side encrypted type object storage, where only you have the keys to your data, or only you have the keys to your company's data. And we can use things like macaroons, which are hierarchical key systems, to determine who has access to what data. And so, right, security by default, talked about that. We kind of talked about these core concepts. But one thing that I didn't touch upon was kind of the economical part, right? And so storage, because we're the only cloud provider that doesn't own any data centers, we're able to sell cloud storage that's really 1/3 of the cost of the big guys. And I think that's really an awesome thing. So you kind of think about what Airbnb is doing to like the hotel industry is somewhat similar to what we're doing with cloud. So just a little bit of an overview of where we're at as a company. So Storj, we initially launched in 2014. We were a token on the Bitcoin blockchain, and we eventually migrated to Ethereum. We are listed on a bunch of different exchanges, and we're launching our open source partner program pretty soon, and so keep an eye on that. And here are some of our partners. Key partners are like Microsoft, Heroku, FileZilla for FTP. Doc.ai is a artificial intelligence and healthcare company. Sonam is a fog computing company. So while we do the compute, Sonam has some ability to do like decentralized, or while we do the storage, Sonam has the ability to do decentralized compute. They're all other kinds of cool companies that we're partnering with, and more that we're announcing actually in the next month, which will be fun. And so So really what happened with Storj is we built this decentralized network. We had a lot of traction. We started to hit a couple of bottlenecks. We hired one of the leading experts in distributed systems engineering and decided to rebuild the network from scratch and build it in Go instead of C. And with the idea of we need to be drowning in data and understanding the health of the network and what's happening and what's going on. So we're rebuilding the whole entire network from scratch. But with and that's V3, and that's going to be launched this fall. But with V2, we had 150 petabytes of data. We scaled to about an exabyte of data, and that's kind of where we started hitting bottle caps. So we're looking to scale beyond exabytes of data for V3. We had 90,000 farmers, and so farmers are the nodes that are hosting the data, right? So while we talked about miners in Bitcoin, they're kind of doing this useless computational function. Farmers are they're producing something that's valuable, right? They're of value. So farmers are just people that hold these encrypted file shards and serve them out, and so they get paid for storing the encrypted file shards, and they get paid for the egress fees for bandwidth for serving them. And so, to kind of go back to the security thing, the farmers have no idea, so as the network scales, it gets harder and harder to pinpoint, as the number of nodes increases, it gets exponentially more difficult to pinpoint where a file is in the network. And really we like to do the analogy of reconstituting these files to be picking out 10 specific pieces of encrypted sand on an encrypted beach, right? So it's basically impossible. And so you'd basically have to figure out where all the shards are, and you need to hack the user's private key. And so it's secure by design in that sense. And that's really where we're kind of shifting this paradigm of cloud storage. We have about 240 million monthly API transactions, so we had a lot of traction with V2. And we're at 33 members. I think I was number 26. We have 225,000 community members, about almost 100,000 followers on Twitter. I think we're at 90-ish something. Some 11 core partners, and we have pretty good funding from cash to cryptocurrency. And so we got some good traction, and really cool company with awesome leadership. And so what is our product? So again, we talked about what is Storj. We're client applications that allow you to build cloud applications that are decentralized in some manner, and client-side encrypted, and so you have privacy built into it, which is really, really core. And it's also cheaper, which is important, right? We talked about the platform, so using this to build on top of. So Storj is S3 compatible, so you can use the Amazon S3 API through Minio and migrate some of your archival storage over, and maybe cut some of your costs for archival storage. So right now we're really good for things like time series data, snapshots, or pre-ETL processing type stuff. We're really good for that and for archival storage, and that's what we're focusing on. Because to get to the content delivery network, we need to reach a certain level of scale, and that's kind of where we're going towards. And as this network grows, it gets more and more powerful. And if anyone here has a data center where they're only using 10% of their disk drive space, looking to becoming a farmer, it's an instant stream of revenue, right? So if you're only using 10% of your disk space, might as well partition part of that and start hosting shards, make money. And so you might have seen maps of other clouds that have other major cloud companies might say, we have 30 nodes globally, 30 data centers in every major continent. Well, we have a lot more than that, as you can see here. So we are really spread globally, and I think it's pretty awesome. And so that's just kind of an overview of the Storj network. So this is a deep dive into how Storj works. We've talked about it a bunch, right? But a user uploads a file. It's encrypted. Only the user has the key to the file. It's then sharded using Reed-Solomon erasure encoding, so that you only need 10 of 20 of the shards to rebuild the file. And there's a network audit, so if one node goes offline, all the shards that node was holding get rebuilt and repropagated across the network. So it's kind of this interesting orchestrated network where if the node goes offline, then you still have that availability and durability that you'd expect. And so we're looking to actually get up to so I think Amazon offers 9 nines availability. We're looking to get up to that. We have a 3D graph where it's configurable. We want to be able to have an SLA assurance of 9 nines availability or more for our customers, and durability, because we don't want anyone losing their files. And so kind of talked about this, right? So the client uploads the shards to the nodes. When the file's uploaded, the node replicates the shards to the farmers for redundancy and resilience. And And then, so the client basically talks to the bridge. So the bridge is also, we refer to as a heavy client. And the bridge is what speaks the protocol language of the farmer and does all the orchestrating. So when they want to call the file back, they send a message to the bridge, and the bridge brings all the file shards back, and then it gets decrypted client side because you have your key, and then served to a customer. And you can actually start building really interesting applications around this too. So you can imagine, right, like Dropbox, right? For example, we were originally trying to build a decentralized Dropbox, so Dropbox right now is just hosted on AWS. AWS is all that data. We wanted to build kind of a client-side encrypted, decentralized Dropbox. And then we realized, well, we can go bigger than that. We can just go object storage. And so now we're an object storage layer. And so right now we have like the storage share application, which is kind of the supply side. So if you're a farmer and you want to get paid, if you have an extra terabyte hard drive, or maybe you're running like NOS array at your house or something, if you're like super techie, might as well get paid for some of these unused resources that you're not using. And that would be through storage share, would be that application. So we have a GUI for it, but also currently an application. We also have like storage client apps, and so we have apps that are built around like file transfer protocols, where you can like quickly, like if you need to send an email to someone and the file is like over the email size limit, you send it to the storage network, it's encrypted, encoded, sent to the storage network, and then resent back. And we also talked about connecting farmers with the renters. So we have the heavy client or the bridge that does that. And that's really a series of like libraries and API endpoints to integrate with your existing applications. And you can use things like MinIO to integrate with Azure Blob Storage or S3 or whatever. And so we have like two main partner programs. We have open source partner program and technology partner program. Our open source partner program allows open source companies to monetize. So right now, if you say are using like Cassandra DB, and you're just using the Amazon hosted version of that, right? Like Cassandra's probably not too happy about that, or like any open source company's not too happy about that. So we actually have a revenue share program where we give some money to open source companies if they bring data to our network. And so we're creating a whole new monetization strategy for open source. And that's kind of, I think pretty awesome. We also have technology partners, people that are looking to build around the storage platform. So our partner vision is, you bring us data, users, all that stuff, and we'll handle eventually billing, but we'll handle all the things like developer tool sets and make it really easy to integrate into your existing infrastructure layer application. And so we think we really deliver unique value for partners. We're economical, so we're cheaper than S3. We're about a third of the price. We're reliable, and so we're trying to get to an SLA guarantee of 7 or 8 nines of availability. We're secure, we're client-side encrypted, highly performant, private, and we're open source. So all of our code's available on GitHub. And that's that. And we talked about V3, I'll kind of skip it because we're kind of pressed on time. But all kinds of awesome stuff that you guys should check out online or chat with me afterwards. And to kind of wrap things up, I think we're really poised for massive growth in this cloud storage industry. We have a really strong open source and developer-focused culture. And we have kind of this distributed storage market presence and a really aggressive product roadmap and really an awesome team. And check us out. And if you guys have any questions, I'm happy to chat through anything right now.